The lab was empty. The lights were off. Dr. Irene Pepperberg had gone home for the night. Alex was alone. Alex was an African gray parrot. He had been the subject of the most extensive language research ever conducted on a non-human animal. For 30 years, Pepperberg had been documenting what he could do with words. Identify objects, describe colors, ask for things, answer questions. But the microphones were still running. And in the dark, alone, with no researcher to perform for and no reward to earn. Alex started talking, not repeating, not performing, talking to himself. He commented on objects in the room. He asked questions into the silence. He practiced sounds he had been struggling with during the day's sessions, not because anyone was listening, not because a grape was waiting as a reward, but because something in him was working on the problem. Alone, in the dark, thinking out loud. When Pepperberg reviewed the recordings the next morning, she sat for a long time without speaking. Because what the microphone had captured was not a parrot mimicking. It was a mind at work, using language not to communicate, using language to think. This behavior, using words as a tool for private cognition rather than social communication, had one known parallel in the animal kingdom: human children. Between the ages of 2 and 5, children routinely talk to themselves when alone, narrating their actions, working through problems, practicing language structures. Developmental psychologists call it private speech. It is considered a critical stage in cognitive development, the moment language becomes a tool for thought rather than just a tool for communication. Alex was doing it at age 12, and he never stopped. Every night the microphones ran. Every night Alex talked to himself in the dark. Every night the recordings added to a picture of a mind that used human language the way humans use it, not just to tell others things, but to think. This is the story of what the hidden microphones heard, and what it means for everything we thought we knew about language, thought, and the distance between a bird's mind and our own. Part 1. The parrot African grey parrots, Psittacus erythicus, are native to the equatorial forests of Central and West Africa. They are medium-sized birds, predominantly grey, with a distinctive short red tail and pale yellow eyes. In appearance, they are handsome, but not spectacular. In cognitive capacity, they are in a category that contains almost nothing else. The African grey has the largest brain relative to body size of any parrot species. Its vocal apparatus, the syrinx, is capable of producing sounds across a frequency range that overlaps almost entirely with human speech. Its auditory system processes speech sounds with a resolution that other parrot species cannot match, but the hardware alone doesn't explain what African greys do. What they do with language goes beyond any other non-human animal studied. They don't just repeat sounds. They learn the meanings of words. They apply words to novel situations. They combine words they have learned separately to describe things they have never seen before. And some of them, the ones who have been studied most carefully, appear to use language when no one is listening. Part 2. Alex arrived in Irene Pepperberg's lab at the University of Arizona in 1977. He was 1 year old. Pepperberg had a hypothesis that most of her colleagues considered unrealistic. She believed that if an African grey parrot was taught language through a specific social method, not reward-based repetition, but genuine communicative interaction between multiple humans, it might learn not just the sounds, but the meanings. She was right. Over the following 30 years, Alex learned approximately 150 words. But the number is less significant than what he did with them. He could identify 50 different objects by name. He could identify 7 colors, 5 shapes, quantities up to 8. He understood the concept of same and different, a cognitive abstraction that requires holding 2 things in working memory and comparing them against a relational concept. He understood bigger, smaller, none. He asked questions, not trained response sequences. Spontaneous questions about things that interested him. When he first saw himself in a mirror, he asked, "What color?" He was asking what color he was. He had no label for the color gray, because no one had taught it to him. He was using language to seek information about himself. Pepperberg taught him the word gray. He never asked again. He had the information he wanted. Part 3. The microphones. The private speech recordings began as an accident. Pepperberg left recording equipment running overnight in the lab, standard practice for monitoring Alex's sleep patterns and any vocalizations that might indicate stress or illness. The first time she reviewed an overnight recording closely, she noticed something unexpected. Alex was talking, not vocalizing randomly, not producing the alarm calls or contact calls that parrots make in social contexts. Talking, using the English words he had learned in the lab, using them in ways that were not simple repetition. He was saying the names of objects in the room, sometimes in sequence, sometimes with apparent corrections, saying a word, pausing, saying it again differently. He was practicing. Pepperberg began reviewing the overnight recordings systematically. What she found across months of data was a consistent pattern of nocturnal private speech. Alex talked to himself most extensively in 3 contexts. After a difficult training session, when he had struggled with a concept or a word during the day, he would return to that word at night, repeating it, varying it, apparently working on the production problem in the absence of any social pressure. When new objects had been introduced to the lab, objects he had seen but not yet been asked about, he would vocalize the object names he already knew, sometimes in apparent comparison sequences, as if categorizing the new object against known ones. And sometimes, for no externally identifiable reason, he would produce strings of words that had the structure of commentary. Words that seemed to describe the state of the room, or his own state, or some internal process that the recording could capture in sound, but not in meaning. He was thinking out loud. Part 4. Private speech. The concept of private speech in human development was first systematically described by the Soviet psychologist Lev Vygotsky in the 1930s. Vygotsky observed that young children routinely talk to themselves, narrating their play, describing what they are doing, working through problems verbally in the absence of any communicative partner. He proposed that this private speech was not meaningless or immature. It was a transitional cognitive function, the moment at which language, originally learned as a social tool, becomes internalized as a tool for individual thought. Private speech precedes what adults do silently, the inner verbal monologue that structures much of human cognition. Children do it out loud before they learn to do it internally. The developmental significance is profound. It means that language is not only a system for transmitting thoughts between people, it is a system for generating and organizing thoughts within a single mind. This is the property of language that separates it most sharply from simple communication systems. A dance bee communicates the direction of flowers. The communication is social and functional. The bee is not using the dance to think about flowers. It is using it to tell other bees where they are. A human using language to think is doing something categorically different. The language is not going anywhere. It is not for anyone. It is the mind operating on itself using symbolic tools. When Alex talked to himself in the dark, he was demonstrating, in the only way an animal can demonstrate it to researchers, that he had crossed this line. Language, for Alex, was not only social output, it was cognitive infrastructure. Part 5. The control question. When Pepperberg and her colleagues began to take the private speech recording seriously, they faced the obvious control question. How do you know he's not just making sounds? How do you distinguish private speech, language used for cognition, from random vocalization that happens to use learned words? The answer came from the pattern analysis. Random vocalization would produce words distributed without structure across the night. Frequency would not correlate with daytime experience. The sequences would not have internal logic. What the recording showed was different. The frequency of overnight private speech correlated with the difficulty of the preceding day's sessions. Harder days produced more overnight speech. Easy days produced less. The content of overnight speech correlated with what Alex had encountered during the day. New objects appeared in overnight vocalizations. Difficult words appeared in overnight practice sequences. The sequences had internal structure. Words appeared in combinations that matched learned grammatical patterns. Corrections occurred, a word produced, then reproduced differently, suggesting that Alex was comparing his output against an internal standard and finding it insufficient. This is not random vocalization. This is practice. This is review. This is the overnight processing of daytime cognitive experience through language. It is what a child does. It is what, in attenuated form, adults do. The mental rehearsal of a difficult conversation. The verbal processing of an unresolved problem before sleep. Alex did it with English. Every night, in a dark lab, alone. Part 6. What language is for the Alex findings force a specific question about language that most people have never had occasion to ask. What is language for? The obvious answer is communication. Language is how we tell each other things. It is a social technology for transmitting information between minds. This answer is correct, but it is incomplete. The deeper function of language, the function that the private speech research reveals, is cognitive organization. Language allows a mind to operate on its own contents in a systematic way, to label experiences, to compare labeled experiences, to sequence them, to identify contradictions between them, to project them into the future or retrieve them from the past. A mind without language can do some of these things, but it does them slowly, incompletely, with difficulty. Language is cognitive scaffolding. It makes certain kinds of thought possible that are impossible, or much harder, without it. When Vygotsky described private speech as the transition from social language to cognitive language, he was describing the moment a child gains access to this scaffolding for individual use. When Alex talked to himself about the difficult word from today's session, he was using language as cognitive scaffolding. He was building the structure that would let him get the word right tomorrow. And he did. The analysis of Alex's overnight private speech on words he struggled with showed a consistent pattern. Sessions where Alex engaged in extensive overnight private speech on a specific word were followed by improved performance on that word in the next day's session. He practiced alone. He improved. The scaffolding worked. Part 7. Not Alex alone. Alex died in 2007 at the age of 31. His last words to Pepperberg the night before he died, at the end of a normal session as she put him in his cage, were the phrase he used every night. "You be good. I love you. I'll see you tomorrow." He did not see her tomorrow. But the research did not end. Pepperberg's lab continued with other African greys, Griffin and Arthur, and the overnight recording protocol continued. Both birds showed private speech behavior. The pattern was similar to Alex's, post-session practice, novel object processing, apparent self-commentary. But Griffin added something new. Griffin was observed on multiple occasions producing what Pepperberg's team described as apparent self-correction sequences, strings in which he produced a word or phrase, paused, then produced a revised version that was phonetically closer to the human model. He was listening to himself, comparing his output to a stored representation of the correct sound, finding the gap, closing it. This is vocal learning, the process by which birds learn to produce sounds by comparing their output to a target, but applied to language not in the presence of a teacher, but alone, using internally stored targets as the reference. Griffin was teaching himself, in the dark, at night, alone. Part 8. The Other Parrots. The private speech findings from Pepperberg's lab have been supplemented by observations from other researchers and from parrot owners who began after the Alex findings became public, paying attention to what their birds said when alone. The reports are consistent. African greys living in homes, not laboratories, show the same behavior. Owners who installed cameras or audio recorders in rooms where their parrots lived alone reported birds talking in the absence of humans, using words and phrases learned in social contexts, apparently without social communicative purpose. The content of home parrot private speech tends to be richer in emotionally significant phrases, words associated with social bonding, comfort, or distress, than the lab bird's more cognitively focused practice sequences. This may reflect the different vocabulary available to a companion parrot versus a research subject, but the structure is the same. Words used alone, language in the absence of communication, mind operating on itself. Part 9. The Distance Question. The Alex findings raise a question that science has no comfortable answer to. How far is a mind like Alex's from a mind like ours? The standard answer, the one that appears in most biology textbooks and most popular science writing, is very far. Birds are not primates. Their brains are organized differently. Their evolutionary history diverged from ours hundreds of millions of years ago. The private speech findings complicate this answer, not because they show that African greys are the same as humans. They are not the same. Alex's language was limited. His vocabulary of 150 words is a small fraction of an adult human's tens of thousands. His grammatical capacity was restricted to simple combinations. His use of language for abstract reasoning was present but bounded. The distance is real, but the private speech shows that the distance is not infinite. It is not categorical. It is a difference of degree, not of kind. Alex used language to think, less extensively than a human, with a smaller vocabulary, with simpler structures. But the operation, the private cognitive use of symbolic language, was the same operation. The gap between Alex's mind and a human mind is large. The gap between Alex's mind and the minds of animals that do not have language is larger. He was not human, but he was not simply an animal either. He was something in between for which we do not have a good word. Something that used the tool we thought was ours alone. In the dark, when no one was watching. Outro. The lab is quiet now. The microphones that recorded Alex's overnight conversations are part of the research archive. 30 years of recordings. The most complete acoustic record of a non-human mind using language ever assembled. Pepperberg has said that reviewing the overnight recordings was the most disorienting experience of her scientific career. Not the daytime sessions, the impressive demonstrations, the correct answers, the cognitive tests passed. The nights. The recordings of a bird in an empty room, in the dark, talking to himself about things that had nothing to do with getting a grape. Working on a word because the word was difficult. Commenting on the room because the room was there. Practicing the sounds of a language that was not his species' language but had become his language. The cognitive tool he used to organize experience, to process the day, to prepare for tomorrow. To think. Every night for 30 years. In the empty dark after the researchers went home, Alex talked. Not for anyone. For himself. Which is to say, for the same reason we do. Next week on Your Backyard Birds, the goose that remembers your face and tells its children who you are. Subscribe. And next time your house is quiet and you think you hear your parrot making sounds in the other room, listen more carefully. He might be thinking.